Hello and welcome back to Let's Code Physics. We are going to make an addition to our cut the rope style game today. So just to review, we've got it set up to where we have a game where we're trying to get the green candy into the red basket here. So I can click anywhere on the rope to get it to cut, and my goal is to get it. Oh, this is really a game of how well can you line up your cursor. Let's see, let's maximize it. There we go. So I can cut anywhere here, and then I can cut on this part of the rope, and my goal is to get in here. But then I encounter a little bit of a problem because this thing is continuing to bounce around, and it can do crazy things like that, right? That's not physical. We don't want that to happen in the game. So what I'd like to be able to do is I'd like to be able to have the game end once the candy gets in the basket. Right, that would be the goal, would be to just have the game pause there and say, congratulations, you did it, world's best cup of coffee, etc. So what I want to do is I want to add in a condition for when the game should end. So let's see here. I need to think about this basket that I've got. So we've created the surfaces. Let's say we've created the surfaces for the basket here. And so what I would need to do here is I would need to define a space in which the, I would want to define a space in which the candy ends up, and then I can check to see whether the candy is in that space. And it's actually going to be real similar to how we set up the check for whether whether you've clicked inside the spring. So let's draw a little diagram to help us figure that out. So let's say I have my basket, and it doesn't really matter how it's oriented because it's going to define a square regardless of whether oriented like a C or like a U or like this or like a backwards C. Oh, this does make a C. That makes a backwards C. Okay. Sorry, getting myself confused. I sometimes try to imagine, okay, the screen is flipped for them, except that screen is not. This screen is. That screen is. I see what y'all see. I think. Pretty sure those numbers don't appear backwards. Anyway, what I would need to define here would be basically to get the inside of this thing. So I would want to basically trace out a rectangle in here. It should be a square, but it might not be. All right, we might make this a really narrow basket, or might make it a very tall basket. So what I would need here, for example, I would need the bottom edge of the top one. So this is the bottom edge of top surface. There we go. I would need the top edge of the bottom surface. Bottom surface. And here I would need the left edge of the right surface. I'm just going to say S instead of surface. I'm getting tired of writing that out. But then I also need this thing, right? And that one doesn't have a surface attached to it currently. And so for that one I would need the left edge of the top and the left edge of the bottom. Okay. I think it's okay. So now the question is, how do I generalize that concept? So say I flip it around, because then I want let's say I were to flip the basket around like this, right? So all the top edge, bottom surface, bottom edge of top surface stays the same, but now instead of the left edge of the right side, I would want the right edge of the left side, right? And then I would want this mysterious side over here instead. And then if I had it as a U, well, then things are really going to change, because then I've got two vertical sides and one horizontal side. So I need to figure out a way to generalize this for any basket orientation. Okay, how do I want to do that? Well, let's think about this in a little bit more So if I think about this in more generic terms, the only reason I have a top surface is because I have a topmost slab. The only reason I have a right surface is because I have a rightmost slab. I don't have a left surface because I do not have a leftmost slab. So another way of thinking about it would be, if I have a topmost slab, then it needs to be this value. If I don't have a topmost slab, then it needs to be based on the one on the right or on the left. Okay. So let's think about this. I might need to just code it for one thing in particular, for one scenario in particular, and then figure out how to generalize it. Let's see if we can generalize it from the beginning. That's kind of fun. Okay, so here we're going to identify bounds of the basket interior. It's a fancy term. It's a fancy phrase, isn't it? So let's see here. Bottom edge of the top surface, but I might not have a top surface if it's shaped like this. Right, so okay, I think what I need to do is, oh, I know what I need to do. Okay. I think I know what I need to do. I think I just need to take the top edge of all of them. Okay, here's sorry, I'm speaking in sentence fragments here. Let me start with a complete sentence. If I'm willing to have a little bit of inaccuracy, I think I can do this easily, right? Well, that's always the case, right? Because if I just grab the topmost edge of all of them, and the rightmost edge of all of them, and the bottommost edge of all of them, and the leftmost edge of all of them, then I will have that square or rectangle encompasses the basket interior. It's too large because, for example, if the candy ever ends up in this corner, then it's done, right? And so, that would work, but then, gosh, if the candy ever ended up in this corner, the game would end, and that's kind of an artificial ending. And the way I've got the basket defined right now, there is a little corner there for it to end up in. I mean, like in this game, the odds of it ending over here are pretty small, right? So I could work to, close up that gap. But I don't find that satisfying. I suppose another way I could check it, instead of defining this box, I could check for whether this box's position is above it, this box's position is right of it, and this box's position is below it. So what I could do, I could define a checker. Here's what I'm thinking. Here's what I'm thinking. Imagine with me for just a minute, and then we will get the thing, underway. Let's suppose I need to meet. Okay. I think I got it. Okay, I think I got it. Okay, I want to find out whether the candy is in this box, right? So let me draw you a little piece of candy here. There is the candy, right? I want to check whether the candy is in the box. Okay. What I could check would be, is there a block? Is there a surface above the candy? Right. And if so, then you add 1 to the counter. So I'm gonna start it with a little checker. So is it in the box? It's gonna start out at 0. So I'm gonna define a variable. Let's call it inbox. Yeah, inbox. So initially your inbox is empty. I'm gonna keep it as inbox because that's funny. If there's a surface below the candy, then you add another one. If there's a surface, this is getting repetitious now, to the right of the candy, then you add 1. So there's an interesting linguistic question. Why do we say something is above and below, but it's to the left or to the right? That's a little, that's Jeremy, are you watching this? Can you get on that mystery for me? Thanks. Or there's a surface to the left of the candy, then you add another one. Now you say, well, here's the problem. There's only 3 surfaces. So what I do at the end is I check whether inbox is equal to 3. The email's in your inbox, then you've won the game. Well, that's easy. I won that game decades ago. Decades? I won that contest a decade and no, that was decades ago we had email, because that was like 1996, 97. Almost 2 decades ago I won that game. Okay. Sorry, I was in high school in the era where email was for nerds. It was not for everybody, and people made fun of you if you had an email. Okay, so we're going to ignore that part. So sorry I floundered for the last 10 minutes or so. Hopefully I've cut out some of it. What we're going to do is we're going to check the candy's location. And actually what I need to do, what that means is I need to save which atom is the candy. Right, so let's see here. Where do I define that? Let's see, we figured that out. Right. Somewhere in here, I thought. Where do I change the thing's color to green? Oh, there it is. Okay. Oh, sorry. That's where I'm setting up the velocities and such. Oh, sorry. Yeah, this is in between the two sections. Okay. And we're going to call in candy equal to n minus 1. Okay? So we only have to check that once. So we're checking the candy. Okay, so we have saved the label of the atom that is holding the candy. And let's see here. So where do we update the positions? We update the positions right here. Okay, cool. Oh, I don't need to do that in the loop because I just need to do that here, right? Okay, cool. So here we're going to start checking. So we're going to say inbox equals 0, just like I said. And let's see here. Let's see. I need to loop over the surfaces. So we're going to have I surface equals 0 because it's going to go from 0 to 2. So we're going to have while I surface is less than or equal to 2 because it'll go 0, 1, and 2 to give us 3. I don't know why we start counting at 0 in these languages, but I just got to go with it. Because that surface list... Oh, does surface list... 1, 2, 3... Oh, no, I do start out with a blank in the surface list, don't I? Yeah, I start out with zeros and all these so that I don't have to start counting at 0. Good for me. All right, inbox. All right, so I surface is 2. There we go. There's the basket. Okay, and before I forget, I surface equals I surface equals I surface plus 1. There we go. All right, so what we're going to do now is we're going to check for whether the this particular surface, this particular wall of the basket is above, below, to the right, or to the left of the candy. And that's pretty straightforward. All I have to do is check its position, right? Because I don't have to worry about it extending in the other direction. I don't have to worry about the size. I have to worry about the position because I'm looking at the x or the y. Cool. Sorry, let me illustrate what I mean there. So for example, I don't when I'm checking for this one, I only have to check whether this surface is above the candy because this surface is going to tell me, oh shoot, I do need to check the fourth one because if the candy ends up over here, it'll meet these two conditions and this condition. So my inbox plan is not going to work. Well, no, actually, it can start out fine that way because it'll go to inbox equal to 3, and then I can check for whether it's met the missing edge. Okay, we'll sort of figure this out as we go. Okay, so while I surface is less than or equal to 3, if surface list, is that what I called it? Surface list? What do I call this thing? What do I call my list of surfaces? I do call it surface list, okay. let's see, if surface list of iSurface.y is greater than atom list of iCandy, iCandy, dot pos dot y. Oh, and this needs to be dot pos dot y. Or copy and paste. Or surface list, or if it's less than, or, and I'll do the same thing with the x thing. Copy and paste, and then I'll change these y's into x's. Not the y on the candy, but the y's on the positions. So this is checking for one of them. Then inbox equals inbox plus 1. Let's all say it together now. You've got mail. All right, wasn't that fun? Let's see. Okay, cool. So that will take care of that, and then we need to see whether whether inbox is equal to 3. So if inbox is equal to 3, right? So if it meets for all 3 surfaces, and now here's where I do need to check whether it's inside. Okay, so how to check? Okay, so I still have the problem of having to identify the missing side. Let's see here. Well, I suppose, okay, I think I'm thinking that the easiest way to do this is going to be to just identify one as the top, one as the right, one as the bottom, one as the left, etc. So let's do that this way. So if that is true, that means it's beating out one of those. So then let's identify which one it's winning out as. So let's test for each one of these. Copy, paste. Then, all right, so that's identifying this iSurface as the top. So iTop is going to equal iSurface. And then we'll do the same thing with the bottom. Because now if I change this into a less than, it identifies this one as iBottom. Right? So now it's saying, hey, the candy is below this one must be the top. Then it's saying, hey, the candy is above this one must be the bottom. And then do the same thing for the x and the y. Copy, paste. X, 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 and X. For the greater, that's going to be I right. And the next one's going to be I left. Cool. Okay, so the question is which one is missing? So what we're going to do is we're going to initially define all of these as -1, right? Because they'll never be -1 if they're identified in here. I top is -1, I bottom equals -1, I right equals -1, I left -1. I left -1 behind. Let's see, cool. So if inbox equals 3, then it means that it was able to identify 3 of these. Oh, wait, there's a problem with this logic. Because, for example, if the ball is to the left of all 3 of them, it'll add up 3 at once. So I actually need to get rid of this one. And then move that. I need to, okay. So I've run into a problem where if I did it that way, then basically if it's outside the box, it's going to trigger all of them because it'll be to the left of all of them, or it'll be to the right of all of them. So what I want to do instead, okay. So now it's identifying a top surface, a bottom surface, a right surface, and a left surface. So actually, let's skip this inbox business, and let's evaluate whether these 4 are all different. Because the only way those 4 will all be different is if it's inside, right? Because if it's up here, then one of these will get counted as right, yeah, then there won't be one above it, right? Yeah, because if it's outside, there won't be one above it, and so one of those will be -1. So let's do this. If, how do I want to do this? Oh yeah, let's just check whether they're equal. If I top, all right, I have to check for them all not to be the same. I have to check for them all to be different, right? Okay. How do I want to do that? Oh, there's probably an easy way to do that. Oh no, wait. Oh yeah. Because one of them will be negative. Okay, so if this thing is inside, all right. Sorry, I just had a lot of thoughts going on in my head. If this thing is inside, then one of these things, I top, I bottom, I right, and I left. One of them is going to be -1. One of them is going to be 1. One of them is going to be 2, and one of them is going to be 3. If I add all those up, I get 5. There's no other way I can get 5. So if I take the sum, I top plus I bottom plus I left plus I right equals 5. I'm trying to overcome my fear of not using the equality. Just help me through it. Help me through it. Then we know that the... Oh, if they're all different, then the game is over, and I don't have to... No, I do still have to evaluate whether it's to the left. Yeah. Okay, so now we evaluate the missing one. Okay. So now we have to do a check one by one. So I'm going to have to brute force this, I guess. So if I top is equal to -1. So if I top is the missing one. So -1 indicates that that's the one that's missing. Right, so if I top is missing, then that means we need to take the top edge of all of them. So then I need to take the, I want to call it top, let's call it y top, sure, is equal to the maximum of the top edge of surface list. Actually, don't I already have a list of top edges? Top list. Perfect. All right, I don't even have to do that again. Top, I just saw that a few minutes ago. Top list of 1, top list of 2, top list of 3, right? Because that's going to say this is the top of the box. Okay, cool. Okay, yeah. So now if, what's the one I'm looking for? Is the candy? Yeah, so I want atom list of eye candy dot position dot y is less than y top. Then we've succeeded. Then we say game done. Actually, no, let's set this up like not done equals false. We'll initialize not done to be true earlier, and it'll run while not done. Cool. And now I can do the same thing for I bottom. Copy, paste. So if I bottom is the one that's missing, I can't imagine a scenario in which I would have it like this, but I guess so. Like you can imagine a trap door, closing around it. So now we say y bottom is going to be the min of the bottom list. Bottom list. And now I want to check for whether it's greater than y bottom. Cool, and now I can do the same thing. You've heard me say it a million times now, and I can do the same thing for the left and the right. Copy, paste. Making copies. All right, I right, and now we'll have x right. I could just call these by the same thing and then just change the thing I'm checking later, but it's more readable this way. Right list, atom list, I candy pos dot x is less than x right. Okay. Now I say if I bottom equals -1. Yeah, this is the way I want to do this. Yeah. Sorry, I bottom now becomes I left. Now I have X left. And now I look for the left list. Left list. Left list. And now I check for the X to be greater than X left. And then not done becomes false. Okay, let's double check this. I've got top, 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 Y less than top. Woo! Bottom, bottom, bottom on bottom, Y greater than bottom. Woo! Right, 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 right. Y, X less than right, right. Left, 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 X greater than left. Woo! Okay, that was fun. Okay, cool. So, all right, so I'm looping over the surfaces while I surface. So that takes care of that loop. Then I check this part. Okay. So here, I better leave some pseudocode so I know what this next block is. Check for whether candy is in the basket. So am I correct? I don't need that inbox anymore. Dude, I am so done with my inbox. I am seriously done with my inbox. I've got like 100-something unread messages. I'm about to declare email bankruptcy. Oh, I have double hash marks above. Okay, so what I need to do is now I need to define a not done. So note done, not done equals true. So we're not done yet. So while we are not done, cool. All right, let's run this thing and see if I have completely ruined it. The beautiful thing is I can always name iCandy not defined. Oh, that's because I called it InCandy earlier. Well, it's probably easier to change InCandy because I have iCandy elsewhere. No, it's ends elsewhere, so I need to replace all my iCandy with InCandy. I like my InCandy. She's a nice lady. There we go. Okay, cool. So it's not falling into the trap that I thought that I was afraid it would. All right, let's see. Now the testing is all dependent upon me winning the game. Okay, it did not stop. Okay, well I haven't ruined it, so that's good. Oh, I wonder if my check is. I wonder if my 5. Am I mistaken on that? 2 plus 3 makes 5. Yeah. Okay. Oh, wait a minute. Wait a minute. Oh, no. Wait a minute. I top equals I surface. Oh, right. It depends on which one is missing. Oh, whoops. Oh, right. I was thinking in terms of I'm going to have a -1 and a 1, 2, 3. No, I'm going to have a 1 and a 1. I'm going to have a -1 and a 1, 2, 3. All right, let's have it do this. Let's have it print inside top, comma, I top. Print inside bottom, comma, I bottom. Print inside right, comma, I right. And I'm not going to print the left for this diagnosis. Okay, cool. So it is checking those appropriately. And yeah, I don't really want that to be printing all that much. It's not taking my input. There we go. Oh, that's going to take forever because the printing is making it go slowly. Why don't we hit Control C? Inside top, inside right, inside bottom. Okay, so it is checking all of those. So that's good. Okay, so I don't actually need to cut it. So it's successfully going inside the top, inside the right, and inside the bottom. Let's hash those out instead. Inside top, inside bottom, inside right. So what I want to check now for is what that sum is. So let's say print sum was 5. F5. Okay. 3, 4, 5, and 1. So it's never going inside there. Okay, so I must have a problem with the... Okay, let's have it print for me, please. Just print this thing. So what is it coming out as this thing? Because I know what each one of those is. Print that, F5. It's coming out as 7? 7? Try 8. 8? 5, 3? All right, let's think about that. So I've got a... these things all start as that. I've got a... Because that should be checking out as... Because I've got it situated just inside the range of the basket, right? Yeah. Because it's below this one. It's... Oh, okay. That's coming out to be 7 because it's to the left of multiple of them, and so that's throwing it off. Okay. Well, then... Well, then I don't... Oh, you know what's happening is okay, so for example, that right one, it's still below that one. It's considering that one to be the top one. Okay. So I can't just be checking every single surface. I need to check whether the surface is on the top, the bottom, the left, or the right. Okay, so what we're going to put in here is we're going to say if... Okay, because the problem, I think the problem it's running into is, for example, it's to the, like when it gets inside the basket, it's still below this one, so it's counting this one as the, okay, but I don't really, do I really care about that? What I really care about, okay, so maybe the summation thing is not the condition to check, because what I really care about is whether I top, I bottom, I left, and I right are all different. Okay, let's roll up our sleeves. If I top... Oh, okay, I was about to say I'm going to need to write 4 factorial, right, because there's 4 of them. So I need 4 factorial, that's 4 times... 3 times 2, no, not 4 factorial, 4 combinations, excuse me. That's 6, so I need to write out 6 things. Or I can just say, if I want to find out whether they're, okay, yeah, let's just do it. Let's just do it the brute force way. So if I top doesn't equal I bottom, and I left doesn't equal I right, and I top, oops. Hang on, how do you make a do not equals? Is it the equals exclamation mark or the exclamation mark equals? I don't know, we'll find out. If I top doesn't equal I bottom, and I left doesn't equal I right, and I top doesn't equal I right, and I top... I should order these differently to better check. Doesn't equal I left. Okay, let's put all the I tops at the first. That's what I should have done. There we go. Okay, I top doesn't equal I bottom. I top doesn't equal right. Top doesn't equal left. Okay, and next I need to check bottom. I bottom doesn't equal I right. And I bottom doesn't equal I left. And now I need to check I right. I right doesn't equal I left. Why are you frowning at me there? I'm doing this right, I think. So that's 1, 2, 3, 4, 5, 6. Okay, so I've got 3 from the top. 1, 2, 3. 2 from bottom. 1, 2, and then 1 from the right. 1. Okay, so that takes care of every combination. Cool. Let's see whether that works. Oh, okay, so that I was wrong about that. Okay, so let's replace doesn't equal with doesn't equal. Oh, I guess I can remember that because this one is equal doesn't and this one is doesn't equal. Okay, replace all. Here we go. 5. Okay, so far so good. Wow, I cut that thing at the very last atom. That did not work. Okay. Why did that not work? Okay. Print, I'm here, exclamation mark. F5. Okay. Hang on, stop. Quit bouncing around. This is testing phase. This is not playing phase. Cut. Okay, it should be there at that point, because it's there. So it should be there. All right. Oh, I'm still running into the same problem, aren't I? Because it's counting this one as the top edge. Okay. Okay. Then. Okay. So what I need to do is I need to make this part a little more fancy. Because I need this part to actually check whether it's checking the actual top of the basket. Okay. So let's do it this way. Well, the first thing let's check is whether I top is equal to -1. So if I top equals -1, right? Because that means, doesn't equal -1, because that means it's been claimed before. Actually, no, let's do it the other way. If I top equals -1, then you change it to this, right? Because it hasn't been claimed before, then we know we don't need to consider any other possibilities. Else, if surface list of iSurface.pos.y, right? Because otherwise, because here iTop has not been claimed. iTop has been claimed, right? Or has not been claimed, excuse me. Else, if surface list of iSurface.pos.y, so the one you're currently checking, is greater than surface. Surface list, you have a lovely face, I'm sure, of iTop.pos.y. Then we need to update iTop. Then iTop becomes iSurface. There we go. And otherwise, if it's getting this one by mistake, basically, then it won't change iTop. Okay, I need to reproduce that for here. Okay, so what I need to do here is I need to say if iBottom equals -1, that means iBottom has not been claimed. He has been claimed. Really weird episode of Lost last season. iBottom equals iSurface. I enjoyed the last season of Lost. I understand why some people didn't, but it's just, it kind of didn't matter to me what happened. I was going to enjoy it, because it was going to be over, and we were going to have some answers, if not all answers. So here we're checking less than to make iBottom equal to iSurface. So we're updating iBottom here. Okay, greater, less. Now we'll do the same thing here. So here we'll do if I write, and if I write, this will work. If I write, will you read? All right, how many puns can I make today? All right, I write has not been claimed. Indent, then we say else if, copy, and now I change these y's into x's. Then I say if that's the case, then iSurface is excuse me, I right is equal to I surface. The reason I don't want to make this into an or, because I could put this condition in with this condition to say if this is true, or excuse me, with this condition and say if this is true or this is true, but that would cause this to try to reference surface list of -1, and I don't want to do that because then it'll throw an error. So this is just to avoid that error. I right equals I surface, and I need to do the same thing for the left. So let's just copy this whole thing, and we'll replace this part here, paste. Here we're looking at I left, left, I left, I left is less than, oops, that's not supposed to be there. That's supposed to be I right, and that's supposed to be I bottom. We'll do our fun musical check in a little bit. All right. All together now. Y greater, greater, Y top, top. Y less, less, Y bottom, bottom. Bottom, top. Okay. This one's not as fun, is it? X greater, greater, right, right, right. X less, less, left, left, left. Okay, let's try this again. F5. It's not letting me click. It's not responding. Oh, did I leave out a something? Oh, whoops. Oh, I thought I deleted something I didn't need. I need to have I surface equal I surface plus 1. F5. Okay, good, good. Okay, it's in that part of the loop now, so it's saying I'm here now. And it is checking for this part, and it's not getting it, and that's why it's continuing to print. Okay, that'll swing very slowly. Okay, let's take out that print statement now. Hash F5. It's going to be great. Come on, quit bouncing around. Oh, got that last atom again. Nice. Cut, 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 cut. Ah, seriously? All right, let's try that again. My knuckles are supposed to make an impressive cracking sound there. All right, you ain't getting away from me this time, Candy. And cut, cut, cut. Cool, it won. It froze the game. That's so awesome. Okay, that is really cool. This episode, I've been recording for about 40 minutes now, so I think we'll call it a day for that. Hopefully it hasn't been 40 minutes from you. Hopefully I've cut out something there. So for a real game, I would want this to actually make it inside a little bit. So, you know, we might put in, actually we could just put in a little buffer where it's that plus a little bit. Yeah, actually, let's do that really quickly. So if atom list is less than Y top, let's say minus, let's say minus a few candy radii. So let's say minus like 3 times the atom list of n candy dot radius. Copy. And so for the bottom, it's going to need to be plus that much. And then for the right, it's going to need to be plus that much. Or no, excuse me, for the right, it's going to need to be minus that much. And for the left, it's going to need to be plus that much. Right, top gets minus, right gets minus, bottom gets plus, left gets plus. Let's do that one. Because I want to have the satisfaction of seeing it actually enter the box and make it a little ways into the box. Only then it did not make it that much. Okay, maybe 3 was a bit too much. You were just thinking this episode was going to be over, didn't you? 5. Okay, here we go again. Maximize. Cut. Good upswing. Good upswing. Cut. Cool. So there it made it a little bit more into it. I might play around that number a little bit more. So, yay, we have a successful game running now. Thank you so much for watching. I know this was a long episode, but we had a lot of fun. I had a lot of fun. We had a lot of fun things to do. And I thank you so much for watching, and I will see you next time. Bye-bye.